22% surge in brightness in a single second, then silence. Observer, you were led here by something subtle, as if the cosmos itself set a hand on your shoulder. Now threesome Atlas has vanished behind the sun, slipping into the one place no instrument can follow. What if absence can reveal more than presence? What are the odds that an object this silent, accelerating, where no force should be, would choose its moment so precisely? A light that blinked once and was gone, leaving only a faint whisper in the background radiation. Let's drift. The blackout began the way quiet things often do, not with alarm, but with a soft dimming of certainty. As the sun slipped between us and the passing formation, every telescope on Earth entered its familiar pause. Solar conjunction, the astronomers call it routine blindness, that arrives whenever the sun becomes the radiant veil between us and whatever drifts beyond. Yet this time, the silence felt different, a stillness layered with unanswered motion, as though something unseen was continuing its journey behind a curtain of light while we stood here unable to follow. In the observatories, the screens faded into noise and the world exhaled into waiting. The last readings before the blackout appeared at 11:42 UTC. They came as paired pulses of brightness captured almost simultaneously by Hawaii's infrared telescope and the European Southern Observatory in Chile. A coordinated flare brief, clean and strangely deliberate. Not the chaotic breath of gas leaving a heated body, not the turbulent plume of a fragmenting surface, but a narrow flash that held its shape before dissolving into the sun's interference. Instruments confirmed the absence of dust. No outflow, no broadening halo, only a spike that appeared, held its line and vanished. And then the darkness settled fully, leaving the data to echo like memory. In the weeks before conjunction, 3 Atlas had already moved through the sky with an unusual steadiness. Its trajectory was hyperbolic, yet so stable it felt almost sculpted by intent. Even its rotation resisted the restless wobble, expected from a body heated unevenly by solar radiation. Nearby 9 smaller companions followed the same arc, their spacing so exact that chance seemed the least convincing explanation. They drifted as though connected by threads too fine for us to see a choreography without sound. Now all of them had passed behind the solar disk, hidden in the brightest silence known to science. Some researchers pointed to precedent. Conjunction blackouts degrade data, distort signals and erase detail. It is natural to lose sight, they said. Yet independent observatories continued scanning the solar edge and reported something more mysterious. Soft bursts of narrow-band interference repeating every 47 seconds, faint enough to dismiss, structured enough to linger in the mind. Nothing conclusive, only the kind of pattern that leaves the observer staring longer than expected, wondering whether the noise is carrying something more than coincidence. Tonight, listener silence becomes its own kind of information. Agencies chose caution. The European Space Agency issued a single line stating that observations were suspended until post-conjunction clarity. NASA postponed briefings, careful, with every word mindful of public expectation. Even the usually active Galileo project maintained rare stillness. In this pause, what remained was the data collected in the final hours before the object slipped from view, a compressed archive of subtle changes that felt more like emergence than decay. The companions warmed relative to the primary body, not from sunlight, but from within. The radar reflections from the main structure weakened, suggesting something about its cross-section had shifted like a surface, adjusting to heat rather than succumbing to it. Astronomers call this interval the blind arc, a passage of 2 quiet days when an object travels unseen. For most celestial travellers, it is a peaceful journey, a predictable loop around light. But 3Psi Atlas carried possibilities that did not fit easily into known models. If it reappears exactly where the mathematics predict, the anomalies may dissolve into atmospheric distortion or instrument drift. If it emerges early or late or at an unexpected angle, then some gentle force beyond gravity may be guiding its path. Traveller the cosmos often hides its answers behind the simplest uncertainties, as though inviting us to breathe with the unknown. For a moment, let us follow the last clear signal recorded before the blackout. At 11:41:56 UTC, Gemini South detected a narrow pulse lasting 4 seconds, sharp, coherent and centered precisely at 1420 MHz. The hydrogen line, a frequency woven into the architecture of the universe used by astronomers to map the sky, and sometimes imagined as the universal channel of deep space communication. A second later, the telemetry fell away, swallowed by the sun's glare, leaving only the question of why that frequency appeared at that moment, at that crossing, at the threshold between visibility and disappearance. Some scientists suggested plasma scattering or solar noise. Others noted the timing, the precision, the return to the spectrum that hydrogen claims as its quiet. For natural objects, alignment of this kind is rare, though not impossible. But the final flare, the synchronized formation, and the steady rhythm before the blackout folded themselves gently into a narrative that resisted immediate explanation. No urgency, no alarm, only the slow realization that the universe is under no obligation to behave within our expectations. It reveals itself at its own pace. Across the southern hemisphere, smaller stations picked up faint harmonics, drifting upward in frequency. Amateur arrays logged soft echoes unverified but persistent. All of them fell near the same moments when Earth turned its blind side toward the sun. These fragments of sound were not treated as answers, but as whispers, hints, reflections that might become meaningful once the object re-emerges. In the Deep Space Network, protocols activated not out of fear, but out of attentiveness, the kind one feels when listening to a quiet room after someone has stepped through a door. Even now, beneath the glow of instruments and the hush of waiting astronomers, review the final clean frames of observation. They study the companions steady in their alignment, no drift, no dispersion, every separation held as though supported by an invisible geometry. In the stillness, one astrophysicist wrote, "The problem isn't what vanished, it's what remained unchanged before the vanishing." And perhaps that is the heart of our reflection tonight. Not certainty, but the grace of not knowing. It's all right to not know. Tonight the stars will keep their silence. In the hours after the blackout began, the world's instruments adjusted themselves like quiet sentinels. Ara scanned the solar perimeter, not expecting clarity, only hoping for a hint of structure within the haze. Nothing appeared at first, only the familiar wash of charged particles and the low hum of the sun's constant breath. Yet beneath that brightness, subtle movements unfolded in the data streams. A repeating flicker, a whisper of interference, a soft reminder that even absence can carry a rhythm. In this gentle uncertainty, astronomers leaned closer to their screens, listening for patterns hidden within noise. The 9 companions, once faint dots beside the primary body, had left behind signatures far stronger than expected. Their internal heat remained steady even as they approached a region where many objects lose themselves entirely. Natural surfaces buckle, vaporize, or scatter under such radiance, yet these remained consistent as if shaped to endure heat rather than resist it. No dust trailed them, no plume marked their passing. They simply held their positions, each following an invisible curve, each maintaining the same quiet distance from the center. Geometry is a kind of stillness, an order without voice. In models across Europe and the United States, simulations attempted to recreate their behavior. They varied mass, temperature, rotation, reflectivity. Yet every natural assumption reduced the formation to chaos, only by introducing gentle, continuous adjustments. Micro-influences too faint to detect directly could the stability be preserved. And so, researchers entertained the simplest scientific truth that something unknown was maintaining the configuration, not violently or dramatically, but with the subtlety of a drifting leaf deciding its own descent. Listener, sometimes the universe speaks loudest through its quietest motions. Caltech analysts suggested a fragmentation event, a parent body shattering into aligned pieces. But fragments do not remain synchronized. They drift, they tumble, they obey entropy's slow pull toward disorder. The companions did none of these things. Even in the final frames before the blackout, they kept the same spacing, the same luminous rhythm, the same whispered pulse of 7 minutes and 49 seconds between their faint brightening cycles. Across continents, 3 separate telescopes confirmed the cadence. It was as though the formation exhaled in intervals. Private correspondence among researchers grew softer in tone, less defensive, more contemplative. Claims of coincidence gave way to quiet admissions that they had never seen anything like this before. Some spoke of magnetic coupling, others of resonance, and a few simply called it an unanswered question. In the language of astronomy, that is often the most honest phrase. Tonight, the universe whispers again, not through certainty, but through distance. Meanwhile, radar arrays measured something stranger still. The primary body, once reflective and sharp in its returns, began to lose clarity. Its surface signature weakened not because it dimmed, but because it seemed to shift, as if the material itself had changed its interaction with light. Some suggested a reflective layer melting. Others wondered if the cross-section had narrowed the way an object might rotate to present less area to incoming radiation. Yet none of these explanations held firmly. They rested in possibility, not proof floating like leaves on the current of theory. And then there was the pulse, the one recorded at 1420 MHz, the hydrogen line. A narrow frequency embraced by astronomers because it belongs to the natural architecture of the cosmos. Hydrogen is the universe's first storyteller, the element that carries the memory of stars long gone. A pulse at that frequency is not noise, it is a kind of alignment between nature and instrument. Scientists debated its meaning with measured voices: solar scattering, plasma reflection, calibration artifact. Each theory carried its own gravity, yet none fully explained why the pulse was coherent, why it appeared at the exact moment the object crossed into the blind arc. As days passed, the blackout deepened. Even the most powerful observatories grew numb to the glare. Engineers stared at motionless graphs, waiting for a single rise in the signal floor. When none came, they continued to wait, because astronomy is at its heart patience woven into mathematics. Somewhere behind the sun, the formation continued its journey unseen, unmeasured, yet not forgotten. Silence is the language of distant worlds. In South America, private spectrographs scanning the solar limb detected narrow bursts of interference. Not strong enough to confirm, but too regular to dismiss. 47 seconds between each peak. The same number echoed in earlier anomalies. The repetition felt like gentle footsteps behind a closed door. A rhythm, but not yet a message. Humans are pattern-seeking beings, but the sky teaches us restraint. Not every rhythm is intention. Some rhythms simply are. NASA's internal teams activated deeper analysis protocols cross-referencing decades of solar behaviour. They searched for historical parallels, events where objects passed behind the sun and reappeared with altered signatures. Most comets brightened, some fragmented. A few vanished entirely, their dust trails dissolving into solar wind. But none behaved as this one had: stable, ordered pulsing and warm from within. It moved through expectancy, like a quiet thought drifting through a half-lit room. At observatories, scientists spoke more softly as the hours collected. Uncertainty brings humility, and humility brings a special kind of clarity. They reviewed the final clean frames again, the companions maintaining their Fibonacci spacing with quiet perfection. Natural spirals appear throughout the cosmos in shells, storms, galaxies, but never this exact, never this unwavering. One researcher described it as delicate control, though no one dared elaborate. Words must be chosen carefully when facing the unknown. A few telescopes detected faint harmonics rising through the hydrogen band. Weak, almost shy. They drifted upward in frequency as though climbing a slow staircase of sound. These were not official detections. They belonged to late-night logs and whispered discussions between colleagues who trusted one another. Data without verification remains only a suggestion, but suggestions can stir wonder. Tonight, traveller, you're not lost in space, you are part of it. The silence of this moment belongs to you as much as to the formation itself. It is a shared pause between questions. Somewhere behind the sun, something ancient still moves, and it's all right to not know. When the final hours of pre-blackout data were laid side by side, a quiet story emerged, one shaped not by certainty, but by a softer drift in the numbers. The 9 companions glowed just a little warmer, not from sunlight, but from within. Their thermal signatures rose gently like embers stirred by a breath that never quite becomes wind. At the same time, the radar reflections from the primary body thinned, as though its surface had shifted into something less solid, less willing to return the echo of our signals. These changes did not claim attention, they invited contemplation. Astronomers studying the patterns realized that no known comet behaves this way near perihelion. Volatile ices burst outward, tails flare, dust trails stretch behind like fading memories, yet here there was no dust, no tail, not even the faint plume of sublimation, only stability, only a kind of quiet defiance of heat. It resembled something conserving itself rather than losing itself, adapting rather than breaking apart. Listener. The cosmos often reveals itself, not in dramatic gestures, but in small refusals to behave as expected. As the blind arc continued, time became a measure of stillness. For 2 days, Earth turned without the object's light touching any telescope. Astronomers leaned into the silence, treating it as data. If the 3-eye atlas returned exactly where the models predicted the anomalies could fold neatly into uncertainty. If it reappeared displaced or with altered signatures, then the silence itself would become the clue. Science often waits at the edge of what cannot yet be seen, trusting that the universe will in its own way finish the sentence. In the meantime, attention returned to the final pulse at 1420 MHz. 4 seconds long, narrowband pristine. Its frequency traced the hydrogen line, the cosmic baseline that underlies much of our radio astronomy. Hydrogen, universal, ancient. The first element to cool from the fire of creation whispers at that frequency. A pulse there is not easily ignored. Some said solar interference, others said coincidence, but the timing lingered in the mind, the signal arriving at the exact moment when the object crossed the threshold into invisibility like a door closing softly behind a traveller, passing into another room. Across the southern hemisphere, amateur arrays detected faint upward drifting harmonics. They were small, nearly swallowed in noise, yet their persistence held attention. They repeated at regular intervals, rising gently through the spectrum before dissolving. Nothing conclusive, yet more than randomness. The kind of subtle behaviour that makes researchers lean back in their chairs, stare at the ceiling, and feel the weight of something unspoken pressing lightly at the boundaries of knowledge. Somewhere around midnight, a senior analyst wrote in her notes, "Silence is the last form of information." She meant that what we fail to detect teaches us as much as what we capture. To the astronomers watching from darkened observatories, the blackout became not an obstacle but a mirror. In it they saw their own assumptions reflected about motion, about heat, about the familiar shapes of natural behaviour. And the absence of those shapes left a gentle ache of curiosity. Meanwhile, the debate over the companions continued. Natural fragments follow predictable patterns. They drift outward, scatter under gravitational tides, rotate erratically. Yet these companions behaved more like a constellation in motion. Their spacing remained almost impossibly steady, as though held by a pattern deeper than gravity. When the brightness variations from multiple observatories aligned into a repeating sequence, each object brightening and dimming in rhythm, the findings were met not with alarm but with quiet astonishment. Even the most sceptical voices softened. The universe, after all, has surprised us before. As data teams at the European Southern Observatory compared timing sequences, they discovered something subtler. The distances between the companions matched a ratio remarkably close to the Fibonacci progression. A natural pattern, yes, seen in spirals of galaxies and the unfolding of leaves, but rarely with such precision. It was not proof of anything extraordinary, only a reminder that mathematics sits beneath the behaviour of things, whether shaped by chance or by design. Tonight, Traveller, the cosmos reminds us that structure and mystery are not opposites. Some technicians propose software artifacts echoes produced by image deconvolution near bright sources. It was a reasonable suggestion. Yet identical spacing had been reported by 4 separate instruments operating in different wavelengths. Errors usually disagree with one another. Agreement, even tentative agreement, invited deeper reflection. One junior researcher phrased it simply: either the telescopes are dreaming the same dream, or the sky is. In the quiet hours, orbital specialists examined models to determine what kind of force could maintain such formation at 68 kilometers per second. Gravity alone could not do it, nor could sublimation jets which push bodies unpredictably. Only coordinated adjustments could preserve the distances precisely. But coordinated adjustments require energy, and energy requires intention, or at least a mechanism not yet understood. The scientists did not leap to conclusions. They breathed through the questions, trusting that wonder does not have to be solved to be meaningful. The memory of Oumuamua rose again in discussions. Its strange acceleration once seemed impossible, until theories of directed outgassing offered partial clarity, but Thrishti Atlas resisted comparison. Where Oumuamua tumbled, this object rotated with serene consistency. Where Oumuamua dimmed unpredictably, this formation brightened with rhythm. Similar beginnings, different stories. The universe rarely repeats itself exactly. In labs across Boston, Tokyo, Pasadena, and Santiago, teams replayed the last clean minutes before the blackout. They searched for tiny deviations, any sign of drift among the companions. Frame by frame, they found none. Every trajectory remained locked, every distance preserved. The cluster moved with such calm unity that some observers described it as a single organism made of separated parts. If this structure survived perihelion unchanged, a deeper question waited in the wings. Would it emerge still aligned, or would the sun's heat peel away the order? If it returned intact, perhaps something within resisted entropy. If it reappeared transformed, then nature would have spoken in its familiar language of change. For now, all remained suspended. The sun hid the formation, and Earth waited between breaths. Scientists prepared for the possibility that the object might shift in its course, even slightly. A deviation of 0.5% could place its post-perihelion path millions of kilometers from the predicted point. Such a change would whisper of forces not captured by orbital equations. Tonight, the researchers rested their calculations and let the data fall into stillness. They reminded themselves that questions do not always require immediate answers. The universe has moved through far longer silences than this. Tonight, the stars keep their quiet watch. And it's all right to not know. As the blackout deepened, scattered observatories across the southern hemisphere continued their nightly vigil. Some watched the sky through small arrays built by amateurs. Others used instruments crafted with decades of precision. All of them stared toward the solar limb, where light became indistinguishable from silence. At first, these stations reported only static, gentle, familiar, unremarkable. But with patience, faint flickers began to surface. Narrow bursts of noise appeared at intervals so regular that the observers paused before dismissing them. 47 seconds between each burst, drifting softly against the sun's overwhelming glare, like ripples brushing the edge of a tide. No one declared the pattern meaningful. Astronomy teaches restraint, especially when the data sits at the border of detectability. Yet the recurrence carried a sort of quiet persistence, and even the most skeptical analysts leaned in just a little more. These bursts were not strong enough to shape conclusions, only strong enough to shape wonder. Behind the sun, beyond the wavelengths, we could trust something continued to move, and this movement breathed a slow rhythm into the world of instruments and waiting minds. Inside NASA's Planetary Defense Coordination Office, teams activated cross-disciplinary reviews. Radar specialists compared the final pre-blackout readings to long-term models. Radio engineers examined the harmonic structure of the faint bursts. Data scientists searched for hidden artifacts in the timing. Each group worked with calm precision, not hunting for revelations but listening for coherence. The sky did not owe them answers. They simply positioned themselves to hear whatever it might choose to share. Somewhere in the hum of the servers, a single truth settled. The anomaly lived not in the event itself, but in the consistency surrounding it. Models mapping the object's post-perihelion position relied on strict gravitational math projecting, where 3i Atlas should reappear beyond the sun's embrace. Most projections fell within a narrow corridor just beyond the western limb. If the object re-emerged inside that corridor, the anomaly dissolved into noise. If it reappeared outside it, even by a small margin, the shift would whisper of forces unaccounted for. Listener astronomy is a discipline built on gentle thresholds. A few minutes early, a few minutes late, a few pixels off-center, each becomes its own kind of question. Meanwhile, the companion's infrared signatures continued to intrigue researchers. During the last 24 hours of visibility, each smaller body grew slightly warmer relative to the main structure. Not enough to alarm, but enough to challenge expectation. Natural rock cools unevenly. Dust fragments scatter heat randomly, yet these companions displayed thermal behaviour more akin to regulation than decay. They dimmed and brightened in soft harmony, maintaining continuity as though guided by an unseen conductor. The data did not accuse. It simply suggested that perhaps the formation held itself together in ways we did not yet understand. At the same time, radar backscatter returned weaker echoes from the primary body. Some attributed the change to surface melting, others considered rotation angles. But a few noted that the weakening was too uniform for random alteration, almost as if the material had absorbed the incoming signal rather than reflecting it. When plotted over time, the decrease formed a smooth arc rather than sudden breaks. This elegance too invited reflection. The universe often writes its mysteries in curves instead of lines. In quiet spaces between long calculations, astronomers reviewed the last frames before the object vanished. The companion spacing remained so precise that even the smallest deviation could not be found. Their geometry resembled a pattern drawn gently upon water, a shape held together by something deeper than momentum. Natural debris tends toward disorder, pulled apart by solar wind, scattered by micrometeoroids, jostled by their own internal imperfections. But this formation resisted drift from beginning to end. Its steadiness felt less like defiance and more like acceptance of a path laid before it. When news of these details spread through the scientific community, conversations softened. Even those who favoured conservative interpretations began to acknowledge the strangeness. In private emails, a Caltech researcher wrote, "If this is coincidence, then it is the most consistent coincidence I have ever measured." Another responded simply, "Let's wait, the sky will tell us in time." Will tell us. Astronomy, after all, is a science of waiting, of letting the night offer clarity at its own pace. Then came the final signal before the blackout, a narrow 4-second pulse at 1420 MHz, detected not by one instrument but by 3 each, an ocean apart. The hydrogen line echoed again, calm, precise, steady. Not a flare, not noise. A single coherent whisper from a region moments before engulfed in solar interference. It carried no message except its existence. And sometimes, existence alone is the message. Traveller. When the universe chooses a frequency so fundamental, it is difficult not to listen with a little more care. Debate followed, but not of the dramatic kind. It was gentle, reflective. Some spoke of resonance in heated plasma, others of sensor drift, but many returned to the timing, that quiet alignment of crossing and pulse. There was no insistence, no conclusion, only the acknowledgement that some questions need the dark before they reveal their shape. Beyond scientific circles, interest grew among amateur observers. They tuned their receivers to the hydrogen band, scanning for any sign of repetition. Some claimed to hear faint tones, others static bursts that rose and fell like breath. Whether these observations held meaning did not matter. The act of listening itself drew people into the stillness that astronomy so often cultivates. To look into the unknown is to participate in its unfolding, even if only through shared attention. In global observatories, radar and optical networks prepared for the object's return to visibility. The blind arc would end soon and telescopes would again glimpse the region behind the sun. Engineers calibrated sensors, adjusted angular predictions, and reviewed historical patterns of similar conjunctions. No one expected drama, only clarity, or perhaps the kind of clarity that deepens the mystery rather than erasing it. For now, the blackout remained intact. The solar veil held its ground. Behind it, 10 silent travellers moved without witness, following a trajectory carved into equations yet open to interpretation. The sky offered no new signals, no new flares, only the soft hum of the sun's eternal voice. Tonight, the world waits in that gentle pause, trusting that the cosmos will speak again in its own time. And until it does, it's all right to not know. When the final pulse before blackout dissolved into solar noise, the world of astronomy settled into a waiting posture. Screens that once displayed bright trajectories now glowed with near motionless graphs, flat lines, gentle fluctuations, the soft static of absence. In control rooms from Pasadena to Darmstadt, technicians watched the data streams with a patience born from years of listening to the sky breathe. They knew that behind the sun the formation continued its slow arc, unseen, yet not forgotten. For 48 hours knowledge surrendered itself to silence. The fading signal carried no distress, no chaos. It simply stopped as though a page had been turned between moments of a story still unfolding. Some analysts described the blackout as a curtain. Others called it a deep exhale of the cosmos. The period had a name in the language of orbital science, the blind arc, a quiet passage when geometry hides motion from sight. Yet this time the darkness felt different. Not ominous, but contemplative, like the stillness before dawn when the world holds its breath. As researchers revisited the final hours of data, patterns revealed themselves through slow repetition. The companion's heat signatures rose gently and held steady, suggesting internal stability rather than reflected warmth. The primary body's radar return weakened with unusual smoothness, as if its surface had softened or reorganized under increasing pressure. None of these behaviors aligned comfortably with the physics of a natural comet, but they also did not reject nature entirely. They simply asked the observers to reconsider the boundary between what is common and what is possible. Throughout the blackout, independent observatories continued to point their instruments toward the sunlit barrier. Some detected faint flickers drifting through the hydrogen band, too delicate to claim as signals yet too rhythmic to dismiss. Others recorded quiet distortions in the noise floor every 47 seconds, the same time interval noted days earlier. The patterns were not strong, not reliable, not decisive, but they were present. And sometimes presence alone is a form of communication, even if unintentional. In quiet conference rooms, scientists exchanged reports with voices softened by uncertainty. They did not argue loudly. Instead, they asked questions that circled gently around the same themes. What preserves formation through solar approach? What regulates heat so evenly? What maintains spacing across thousands of kilometers? None of these questions demanded extraordinary explanations. They simply remained unanswered, drifting like distant stars in a sky not yet mapped. Meanwhile, orbital models continued to run on clustered servers. They repeated the same projections countless times. 3. Atlas should reappear on the far side of the sun along a narrow corridor defined by its inbound vector. The math insisted on calm predictability. But the scientists studying that math reflected on a quiet truth. The universe does not always honour our expectations. It moves according to laws we understand and laws we have yet to meet. Somewhere during the long hours of silence, a researcher at ESO wrote in her journal, "Perhaps the most honest part of science is the pause." She meant that intervals of unknowing are not failures. They are invitations. The blackout became one such invitation, a moment to breathe, to ground oneself, to let the cosmos speak in absence rather than abundance. And as the sun turned, Earth turned with it. The instruments kept listening even when nothing arrived. The stillness grew gentle, almost soothing. In this quiet, the formation's last confirmed data point lingered like a small lantern, energy increasing, not fading, alignment holding, not drifting. These details did not push toward conclusions. They simply rested in the collective mind of those who had watched the object for months. Listener. The universe often asks us to be patient. It reveals itself not with answers, but with rhythms, some steady, some irregular, all worthy of attention. Tonight, as the blackout deepens, we wait not for certainty, but for the return of motion across the sensor fields. The sky has not abandoned its story. It has only turned a page we cannot yet read. And while we wait, there is comfort in this silence. A reminder that knowing is not the only way to belong in the cosmos. Tonight the stars keep their quiet watch. And it's all right to not know. When the first scattered observations emerged from independent radio stations across the southern hemisphere, they arrived not as revelations, but as murmurs carried through static. Amateur astronomers in Argentina noted soft harmonics drifting upward through the hydrogen band, faint enough to doubt yet steady enough to log. Hours later, another station in Western Australia recorded something similar, a rise in frequency repeating in the same gentle cadence. None of these detections were strong, None were precise, but together they formed a kind of low, persistent whisper, threading through the silence of the blackout. Scientists approached these reports with the patience the cosmos requires. They reviewed each dataset, examining timestamps, noise floors, calibration logs. Some concluded the patterns were coincidence. Others wondered whether the signals reflected the last residual echoes of the object slipping behind the sun. A few simply wrote the word interesting in their notes and waited. Astronomy is at its heart an art of waiting, of allowing the universe to speak in its own slow language. Inside NASA's analysis rooms, quiet discussions unfolded about the nature of the pre-blackout brightness surge. The coordinated flash seen by telescopes in Hawaii and Chile still lingered in the minds of engineers. It was too clean for a thermal flare, too brief for dust release, too aligned to dismiss as noise. But scientists did not leap to conclusions. They let the data rest like a stone dropped into still water, waiting to see how the ripples settled. The blackout provided that stillness and enforced pause between observation and interpretation. With each passing hour, researchers found themselves returning to the most fundamental patterns: the companion's unwavering spacing, their rising internal heat, and the absence of any tail or debris. Natural objects resist such consistency near the sun. Even the most stable asteroids reveal subtle fractures or chaotic jets when exposed to peak solar radiation. Yet here the structure remained composed until the very last frame. It was as if the formation moved with a quiet confidence, untroubled by the star whose gravity sculpted its path. When teams compared visual data from multiple observatories, another detail emerged. In images taken moments before the blackout's slight fluctuations appeared in the companion's brightness. Not random flicker, but sequential variation, each object brightening in order separated by equal intervals. The pattern repeated over hours too orderly to dismiss as chance, too gentle to claim as extraordinary. These are the kinds of moments where science leans into humility, acknowledging that nature can produce harmony in unexpected ways. Meanwhile, computational models attempted to replicate the formation's behavior. They simulated outgassing jets' magnetic coupling gravitational resonance. None could produce the synchronized motion observed. Only when researchers introduced slight continuous course corrections, nearly imperceptible, did the simulations align with the observations. And this raised a question not of artificiality but of mechanism. What unknown property of material or motion could enable such subtle cohesion? The question did not demand an answer. It simply opened a quiet doorway into deeper reflection. In the halls of JPL and ESO, scientists spoke with lowered voices. They debated without urgency, as if aware that the sun itself was granting them time to think. A few noted that even if the object re-emerged exactly where predicted, the anomalies would still deserve contemplation. Precision, after all, carries its own kind of poetry. And if the object reappeared elsewhere, even slightly off track, the shift would not be alarming, only illuminating. The cosmos offers corrections the way a river offers, bends naturally quietly without intent. As the blackout persisted, dozens of telescopes continued scanning the solar perimeter. Most returns were flat as expected, yet occasionally a trace appeared, a flicker, a dip, a thin distortion in the radio floor. These signals were too faint to analyse, but they hinted at movement behind the glare. Not proof, not pattern, only presence. Listener, sometimes the universe asks us to trust presence long before it offers clarity. One analyst reviewing the noise wrote in her log, "Absence is not empty. It is structure we have not yet learned to read." In those words lived the essence of the blackout. It was not a void, but a space between breaths, a quiet in which thought could settle and expectation could soften. The blackout became less a problem and more a moment of cosmic stillness, a reminder that the universe does not hurry on our behalf. Meanwhile, anticipation gathered gently in observatories worldwide. Instruments were recalibrated, angular predictions refined. Teams prepared for the moment when the sun would shift enough for the formation to re-enter human sight. There was no urgency, only patient readiness. Astronomers understood that whatever re-emerged, aligned or scattered, brightened or dimmed would deepen the story rather than end it. For now, Earth and Sun continued their ancient dance, leaving the object hidden from view. The silence of the blackout wrapped itself around the scientific community like a soft blanket, encouraging stillness, reflection, and humility. The cosmos was composing something behind the sun, but did not yet turn the page. Tonight, as the world waits beneath star-filled sky, one truth settles quietly across every observatory. Silence is also a form of information, and it's all right to not know. When the first deep space instruments regained partial clarity along the solar perimeter, the readings that appeared were quiet at first, small distortions in the ultraviolet band, brief pulses of radiation that did not match the sun's natural signature. The Solar and Heliospheric Observatory, drifting in its eternal post between Earth and star, recorded a narrow flash, occurring precisely at the object's closest approach to the corona. Its profile was symmetrical, almost elegant, unlike the uneven bursts that solar flares produce. And after that flash, nothing, no plume, no debris, only stillness returning like a tide. To the scientists reviewing the data, the absence was more striking than the emission. Natural objects betray themselves under the sun's intense heat. They scatter dust, shed ions, cast bright streaks into space. But here the void remained clean. In astronomy, emptiness is almost never perfect. Yet, this one was. The analysts stared at it quietly, acknowledging that nature had once again offered them something subtle, something that resisted easy explanation. Hours after that ultraviolet pulse, the Parker solar probe tracing its difficult orbit through plasma, and charged wind detected faint interference near its telemetry band. The signal repeated at a frequency that had already become familiar to researchers, 14-20 MHz, the hydrogen line. The reading was weak, nearly drowned in the sun's roar, yet structured enough to stand out. Engineers debated whether it could be a reflection of Earth-based noise, but the probe was far beyond terrestrial reach. A quiet possibility drifted through the room, not as a conclusion but as a thought. Softened by uncertainty, the pattern had followed the object into the heart of solar brightness. In the scientific world, such coincidences are handled gently. The hydrogen line is universal, and interference is common. Yet the repetition, the same timing, the same faint upward drift in frequency, gave the data a kind of calm persistence. It did not demand attention. It simply remained like a small stone resting where a river meets the shore. Listener. The cosmos sometimes speaks not in messages but in consistencies. Back on Earth, the Companion's heat readings continued to puzzle researchers. Near perihelion, their temperatures should have risen sharply and then fallen as they shed mass. Instead, they remained stable, as though insulated from the turmoil around them. No jets erupted from their surfaces, no vapor trails formed. They behaved neither like rock nor like ice. They behaved like something maintaining its own conditions quietly without haste. To explain the stability, scientists explored models that stepped cautiously beyond familiar terrain. Could metallic surfaces radiate heat differently? Could exotic ices sublimate in ways that concealed plumes from infrared sensors? Could resonance within the objects mimic thermal regulation? Each idea carried its own elegance, its own set of complications. None fit perfectly, but each offered a small piece of a larger puzzle. Astronomy, after all, is a mosaic built from fragments of light. Official agencies kept public statements conservative. The event was described as anomalous yet likely natural. Reports promised clarity once the object reappeared. Privately, though, teams revisited every line of data with newfound attention. When the 1420 MHz pulse aligned perfectly with the moment of solar conjunction, a note of curiosity entered nearly every internal memo. It was not alarm. It was not speculation. It was simply interest, the quiet kind that precedes understanding. Elsewhere, private observatories examined the faint dips recorded in extreme ultraviolet scans. Their timing echoed the established rhythm of the object's rotation, an 8-minute variation observed earlier in its journey. If the modulation truly matched its spin, then perhaps the object's shape or surface emitted or absorbed energy, in ways still hidden by the solar veil. Or perhaps the dips were artifacts of observation illusions formed at the boundary between brightness and shadow. Both possibilities held value. both invited patience. Meanwhile, the question of energy returned. The heat signatures of the companions did not behave like inert matter. They rose with intention, maintained consistency, and refused to scatter. If this were natural, it belonged to a category not yet described, a state of matter or structure, shaped by conditions unfamiliar to our solar system. Some researchers proposed that unknown material composition might be responsible. Others wondered about internal mechanisms that could regulate heat, though this idea wandered close to speculation. In the realm of the silent cosmos, speculation is not forbidden. It is simply held softly like a feather cupped in the hand. Through long nights, data analysts ran simulations across supercomputers. They varied mass density, reflectivity, rotation, radiation pressure. None of the natural models preserved the formation through perihelion without distortion. Only deliberate modulation, small corrections applied continuously, could sustain the harmony. But even that interpretation did not demand artificiality. It could suggest unknown physical properties, new ways of interacting with solar energy, or structures evolved in environments far different from our own. The sky remained quiet, but the instruments were not. Satellite arrays monitored the solar edge, recording every fluctuation with care. Some detected faint harmonic, short-lived ripples that passed through telemetry bands and dissolved almost instantly. They did not claim the ripples as signals. They simply added them to the growing list of subtle events marking the blackout. Patterns do not require meaning to be beautiful. In the midst of this stillness, a researcher at JPL remarked in a late-night call, "Perhaps the universe is teaching us to slow down." His colleagues agreed. The blackout was not an interruption, it was part of the narrative, a necessary pause, a place where doubt could breathe and discovery could approach gently rather than all at once. At last, as the blackout neared its end, telescopes across Earth prepared for reacquisition. Instruments cooled, mirrors aligned, algorithms refreshed. There was no tension in the air, only quiet anticipation. Whatever re-emerged familiar or altered would carry the next chapter of the story. Nothing was required from the observers except their attention. Traveller, the universe moves at a pace older than thought. It reveals itself with the kindness of distant tides. Tonight, let the unknown rest where it is. The stars will keep their silence for us. The return of the formation did not come from the largest observatories, but from a quiet hillside in northern Chile, where a group of dedicated skywatchers had continued their nightly recordings despite the blackout. For nearly 2 days, they saw nothing but the usual glow of solar interference. Then, just before dawn on November 1st, their instruments detected something faint. A cluster of thermal signatures, 10 in total, appeared at the very edge of the sun's exclusion zone. It was subtle, almost shy, yet unmistakably patterned. At first they assumed it was sensor echo, but when independent datasets echoed the same points, a new stillness settled across the observing world. 3 nights passed before the Chilean team felt confident enough to share their findings privately. The alignment, spacing, and intensity mirrored the last confirmed configuration of 3 Atlas and its 9 companions. Nothing drifted, nothing scattered. Each source maintained its proportional distance from the center, as if the formation had passed through the sun's radiance without losing even a breath of its original structure. Natural objects rarely keep such composure. Heat disrupts them, light unravels them. But here, the reappearance carried the gentle poise of something that had simply continued its path. What startled astronomers most was not the geometry but the timing. Orbital models predicted that the object would remain hidden until early December, yet here it was barely 72 hours after vanishing, emerging into view once again. It had returned earlier with a softened brightness and a slower drift across the sky. Calculation suggested that its velocity had fallen from 68 kilometers per second to around 54. The drop was smooth, gradual, and free of the chaotic fragmentation that natural deceleration typically requires. In the quiet halls of observatories, researchers exchanged long glances rather than quick words. Some explored the idea of solar drag, imagining magnetic interactions that could slow the formation during its passage. But the sun pulls more than it breaks. Its winds push outward. Its gravity accelerates. Its radiance strips away surface layers. To lose speed in such an environment without shedding mass is uncommon. To lose speed while maintaining synchronized formation is rarer still. Yet no alarm rose, only contemplation. The universe often moves in ways that challenge our assumptions gently rather than confront them. When the data reached Europe, analysts examined every timestamp, every pixel. The formation's trajectory had shifted north by a few degrees, not dramatic but meaningful. Small changes echo across large distances. A shift of 3 degrees near the Sun becomes millions of kilometres farther out. Yet the new path unfolded with the same steady grace as before. It curved toward the outer solar system, lifting itself toward Jupiter's orbital plane, with a calmness that suggested purpose, though science does not name purpose without evidence. NASA responded cautiously. The agency requested raw telemetry but offered no interpretation. This restraint was not secrecy, it was discipline. To speak too soon is to misrepresent the cosmos. Instead, researchers returned to the brightness curves. The object glowed differently than before. Its spectrum leaned toward metallic reflection, the green hue softening into something more uniform as though the surface had cooled or reorganized. No tail rose behind it. No spray of dust followed its wake. Just a solitary glow surrounded by 9 quieter embers. Across private laboratories, scientists compared this new radiance to earlier readings. The companions emitted heat without producing visible light, a combination difficult to reconcile with natural cooling. Though nothing in the data insisted on interpretation, many recognized the elegance of the behavior, steady, measured, precise. A researcher in Buenos Aires described it as light that knows its own boundaries, though the phrase was more poetry than physics. Over days, the object's post-conjunction path became clearer. The formation was not leaving the system immediately as expected from a hyperbolic traveller. Instead, it seemed to curve gently, aligning itself with a trajectory that would cross near Jupiter by mid-2026. Natural bodies rarely choose such paths, but gravity can guide in unexpected ways, and orbital dynamics often reveal hidden harmonies in motion. In the silent cosmos, even coincidence can feel like choreography. As the news spread quietly through observatories, humanity returned to watching with renewed softness. Researchers recalibrated their instruments. Amateur astronomers updated ephemerides. Global networks aligned their attention toward the deepening night. No one claimed certainty. No one forced conclusions. The formation moved through collective awareness like a drifting lantern, steady, gentle, guiding thought rather than demanding it. One scientist wrote in her log, "Even if this is only nature, it is nature beyond our familiarity." Her words captured the mood across the scientific world. The re-emergence was not proof of anything extraordinary. It was simply different enough to slow our thoughts, to encourage humility, to remind us that the cosmos still holds room for questions shaped like wonder rather than urgency. And as the formation continued to drift across the darkening sky, the silence around it deepened in a soothing way. Observatories across continents paused between measurements, letting the quiet fill the spaces between data points. The blackout had ended, but a new kind of stillness took its place, one woven not from absence but from gentle curiosity. Listener, it is in moments like this that astronomy becomes less about answers and more about presence. The stars do not rush, and neither must we. Tonight the universe whispers again, and it's all right to not know. As November unfolded, the world of astronomy shifted quietly into a deeper form of listening. The largest telescopes, radio dishes, and orbiting instruments began coordinating their schedules not through urgency, but through a shared desire to understand what the re-emerged formation was becoming. Signals at the hydrogen line grew clearer than before. The once faint pulses now carried structure, 3 gentle peaks repeating in rhythm a pattern, familiar yet newly sharpened, like a voice returning with more strength after rest. At 2:19 UTC on November 16th, the next pulse arrived. It unfolded across receivers with the calm certainty of something that knew its own timing. 47 seconds separated each amplitude peak, the same rhythm observed before the perihelion blackout. But then came a 4th peak, softer and more delicate than the others, drifting slightly out of phase. Scientists leaned in, not with alarm but with a sense of witnessing something evolving before their eyes. Even in the stillness of night, the data carried an almost tactile gentleness. Moments later, optical telescopes captured the first clear curve of the formation, emerging from the sun's diminishing glare. What appeared was not a single elongated body nor a loose cluster of fragments, but a configuration as a disk-like pattern of 10 faint points set in a rotating plane. 9 dim companions circled a luminous center, each holding its spacing with a serenity that felt almost sculpted. The movement was slow, smooth, delicate. If gravity alone shaped it, then gravity was behaving in ways not yet described. Researchers studied the spacing, noting its perfection. Distance ratios aligned across the circle with near mathematical symmetry. Even as the objects rotated, their relative positions remained calm, unbroken by drift. Natural clusters rarely maintain such constancy. They breathe and pulse and scatter under the influence of solar wind, yet here everything held. The sky, it seemed, was presenting a quiet geometry. As Earth rotated, observatories in Chile, South Africa and Australia captured the reflection patterns. The brightness increased gradually, not from intrinsic emission, but from the objects aligning themselves in a way that maximized their exposure to sunlight. It was a soft unfurling, as though the formation turned a face toward illumination, with intention rather than chance. Scientists noted this behavior, carefully acknowledging that light alone was only part of the story. Radio arrays soon detected another kind of signal, a brief sweep between 2.1 and 2.3 gigahertz, gliding like a slow brushstroke across the spectrum. The sweep lasted only seconds, then disappeared. Engineers compared it to uplink tests used by human spacecraft, though the resemblance was merely structural, not declarative. Still, the moment was held with reverence. It joined the growing collection of subtle events that asked researchers to breathe rather than conclude. When NASA, ESA, and China's CNSA issued a joint statement acknowledging the existence of an unknown signal pattern, their words were measured almost gentle. They avoided speculation. They offered no theories. They simply affirmed that something consistent was unfolding in the data and that the coming weeks would require careful observation. It was the kind of acknowledgement science offers when mystery deepens in a way that invites humility. Meanwhile, a team at Harvard's Galileo project released their own carefully phrased analysis, noting that the stability of the signal timing suggested structured emission. The phrase did not claim intent. It merely described the behavior steady intervals, refined coherence, growing clarity. Even the skeptics recognized the beauty in the pattern. It was not a message, it was a rhythm. In the following night, something even quieter emerged. The formation's velocity increased not abruptly, but with pastoral smoothness. 6 kilometers per second gained over 24 hours, a shift too gentle to attribute to outgassing, too deliberate to ignore. The change mirrored the earlier deceleration before perihelion, forming a symmetry of motion that felt like a quiet nod to those watching. As the formation pressed outward from the sun, its trajectory curved toward Jupiter, aligning with a corridor mapped by gravitational possibility. It traced a path that spacecraft often follow when using the gas giant for a slingshot maneuver. Yet here, no plume, no exhaust, no volatility marked the acceleration. Only the silent reshaping of a journey. Within JPL's control rooms, teams watched as tiny harmonics began to drift across the hydrogen line, minute changes in frequency that hinted at something fine tuning itself, adjusting as it moved. The pulses arrived at regular intervals, each shortening by fractions of a second over the course of days. A countdown, some whispered softly, a calibration others preferred. The interpretation mattered less than the steadiness with which the changes came. By late November, warmth readings revealed a subtle wave moving across the outer companions. Each object brightened in heat, then dimmed one after another, as though a soft current passed through them in sequence. The interval between temperature rises matched the 47-second rhythm. The formation was behaving like a single system rather than 10 separate travelers. Travel of the universe sometimes arranges itself in ways that feel intentional, even when we do not yet understand the mechanism. To witness such patterns is not to leap towards certainty, but to acknowledge wonder. As researchers traced these waves across the objects, they noticed how the temperature modulation aligned with slight shifts in their rotation. It was as though movement, heat, and pulse existed in a shared harmony. Even if natural, it was exquisite. Even if random, it was beautiful. The cosmos has always been capable of elegance. During long nights, analysts charted each pulse, each shift, each quiet modulation. When plotted, the intervals formed curves that narrowed toward a single date, December the 6th. This date had already marked the expected period of the object's full emergence from behind the sun. Now mathematics echoed it. Nature seemed to lean gently toward it. No one panicked. No one declared significance. Instead, they prepared. Telescopes across the world synchronized their schedules. Deep space networks cleared their channels. Observatories dimmed their lights and waited beneath skies trembling with cold clarity. And through all of this, the signals continued soft, rhythmic, patient. Tonight the universe whispers through timing rather than words, and it's all right to not know. As December approached, the movement of the formation grew more defined, unfolding with a serenity that felt older than calculation. It had now crossed the orbital path of Mars and entered the quiet corridor of space leading toward Jupiter. Its velocity, once steady, began to rise with a graceful acceleration like a distant tide, drawing forward rather than rushing. 61 kilometers per second. Then a little more. Nothing abrupt, nothing chaotic, only the soft suggestion of momentum shaped by forces not yet charted. Agencies around the world named the formation differently. Object 31A, Cluster Ecliptic Array. Target 0, but each name carried the same reverence for the unknown drifting across the edge of human understanding. Public statements remained cautious, describing magnetic anomalies and observational gaps. Yet within the dim offices where scientists worked late into the night, the feeling was quieter, more reflective. They watched not expecting answers, but recognizing that something meaningful was unfolding with the patience of celestial mechanics. The hydrogen line pulses shifted again, their rhythm tightening. 47 seconds became 41.8, then continued along a gentle curve that pointed toward a single moment. December 6th, 23:11 UTC. The predicted time when the formation would slip behind Jupiter's shadow. The symmetry between motion and signal invited contemplation. Was the sky synchronizing its rhythms, or were these rhythms products of human patterns seeking minds in the silent cosmos? Both possibilities can coexist without needing to contradict each other. As the date neared, observation platforms across Earth and orbit recalibrated for the event. Even the Lunar Gateway, still early in its construction, angled its sensors toward the Jovian limb. Anticipation spread not as tension but as quiet preparation, like adjusting a telescope before nightfall. The gas giant shimmered in instrument feeds, its bands glowing in slow currents of light, and somewhere far ahead of it the formation drifted toward a shadow deeper than night. Then came the glints, tiny flashes reflected from the central object, aligned almost precisely with the times Earth-based telescopes were scheduled to observe. Out of 10 observation windows, 9 captured those micro-reflections within seconds of prediction. Some called it coincidence. Others noted that coincidence itself is a language of the universe. The reflections were soft, like acknowledgements rather than declarations, as if the object simply turned a surface slightly toward us at the right moment. Spectral analysis added another layer to the story. The central object's reflectivity no longer matched any known natural surface. It shone with gradients of nickel-chromium and silicon carbide materials that in nature form in layers only under exceptional conditions. No fractures appeared, no mineral veins, no asymmetry. It was smooth in a way that felt almost intentional, though science refrains from such words without extraordinary proof. Still, the data spoke quietly of structure of order resisting the chaos of heat. Far away, Jupiter's magnetosphere reacted before human instruments did. The Juno spacecraft recorded fluctuations like the soft trembling of an unseen string. Bursts of charged particles rippled outward, carrying a rhythm faintly echoing the formation's pulse. Not identical, but sympathetic, like two instruments tuning toward harmony. The disturbance wasn't violent. It was subtle, almost respectful, a passing wave that hinted at interaction rather than intrusion. On Earth, scientists debated the cause. Solar wind harmonics, metallic resonance, a coincidence shaped by overlapping fields. No explanation satisfied entirely, yet none demanded the extraordinary. Instead, researchers accepted the simplest truth: the gas giant was reacting to something moving toward it, and the reaction was smoother than expected. Silence again became a form of clarity. As the formation approached Jupiter, the hydrogen line pulses continued, each arriving with slightly greater amplitude. Some theorized that the object's orientation or rotation was aligning the pulses with Earth. Others proposed that the pulses acted as a form of internal calibration within the formation itself, signals maintaining rotational synchrony across its 10 components. Whatever the cause, the pulses grew cleaner, more defined, carrying a sense of calm precision. Traveller, even in the vastness of space harmony, can arise from forces we don't yet understand. At 23:11 UTC on December 6th, the moment of alignment arrived. The formation entered Jupiter's shadow, a place where sunlight cannot reach, where even reflected glow disappears. Telescopes saw nothing. Radio arrays fell silent. And then, as if honouring its own rhythm, the pulse stopped. Not gradually, not distorted, a clean, simple ending, a breath held. 32 seconds passed long enough for wonder to gather in the stillness. Then a single continuous tone emerged at 1420 MHz, 1 minute and 21 seconds long, pure, stable, unwavering. It carried no modulation, no encoded structure, only clarity, like a tuning fork resonating in the deep. Scientists listened, humbled not by the sound itself but by its gentleness, a tone that didn't shout but simply existed. What followed shimmered through data streams like the faint echo of a distant tide. Juno detected a spiral in Jupiter's magnetic field, brief yet unmistakable, aligned in perfect timing with the tone, as though the planet had answered with its own resonance. The interaction left no visible mark, yet its presence lingered in telemetry like a soft afterimage. Minutes later, deep space antennas registered something impossible to track in real time, a sudden acceleration. 10 points of light once drifting through gravitational balance now surged beyond detection, moving faster than instruments could follow. There was no explosion, no plume, no residue. Only departure, clean, silent, purposeful, or simply natural in a way still unknown. By dawn, telescopes searched the region where the formation should have emerged. Space was empty, unbroken, serene. Some described the absence as unsettling. Others found comfort in the quiet, recognizing that the cosmos has always carried mysteries beyond the reach of current understanding. The tone faded, the harmonics stilled, but the silence that followed felt like a closing chapter rather than a vanishing. Listener, the universe does not lose what it chooses to carry forward. Somewhere beyond Jupiter's orbit, motion continues unseen, unmeasured, but not erased. Tonight the stars keep their gentle watch, and it's all right to not know. For months now, the story of Three Eye Atlas has unfolded like a quiet thread woven through the deeper fabric of the sky. And as the days pass beyond its disappearance, the data that remains grows softer, thinner, more like an echo than a signal. Yet even that echo carries shape. Researchers across observatories continue listening, tracing the remnants of the hydrogen line, studying the faint distortions that move through the background radiation, as though the universe itself is absorbing what has passed and releasing it slowly back into the silence. Nothing is loud anymore. Nothing is abrupt. What lingers behaves more like memory than motion. Across the deep space network, instruments still detect small fluctuations in radio noise patterns that seem to repeat, but never insist, gentle pulses that drift like ripples spreading across an undisturbed lake. Some scientists call them artifacts, others call them coincidences, few simply call them reminders. They rise and fall with almost a rhythmic patience, never demanding interpretation, only inviting it. When plotted over long intervals, the fluctuations trace a curve that looks less like a message and more like a breath, a slow expansion, a slower release. Perhaps it is only physics. Perhaps it's only the mind noticing symmetry where none was intended. But night after night, the pattern returns steady enough to study, faint enough to doubt. Far beyond Jupiter's orbit, probes continue to relay their last clean measurements. Voyager 2, aged and drifting through the outskirts of the heliosphere, captured a brief tremor in plasma density. Just a moment. Just a pulse. Just long enough to resemble what the formation once produced when it moved inside the solar wind. No one claims certainty. No one tries to shape the data into meaning it cannot hold. Instead, the readings are accepted the way stargazers accept the glimmer of distant suns present but too far to grasp. Even the most careful analysts acknowledge that space often reflects the memory of events longer than the events themselves. A field disturbed once can continue vibrating long after the source is gone. Within research circles, the discussions have quieted. The tone has shifted from urgency to contemplation. Models no longer attempt to predict where the formation has gone, nor attempt to follow its impossible acceleration into the dark. Instead, the focus has turned inward toward understanding what its presence taught, rather than where it might now be. Traveller. Much of astronomy is not pursuit, but patience, the acceptance that some objects move beyond our reach, and leave only the faint geometry of what they once were, a geometry we interpret as best we can. Here too, patience becomes the instrument. A number of observatories working independently have reported localized anisotropies aligned roughly with the formation's departure vector. These variations are tiny, almost imperceptible subtle shifts in background temperature and radiation. Not signals, not phenomena, only slight deviations in the equilibrium of the cosmic microwave background. They persist for hours, then fade, then return again days later. Each time the variation is smaller, as though dissolving naturally into the cosmic noise. The scientists studying them describe the effect not as communication, but as resonance, a gradual settling of the sky after something passed through it. Jupiter's magnetosphere still shows hints of modulation, a low harmonic embedded within its field lines. The wave is stable now, less pronounced, but undeniably present. Probes record a cycle that aligns with earlier fluctuations, a continuity that suggests the event left a temporary imprint upon the planet's magnetic shell. This too is treated not as a sign of intention, but as a natural consequence of interaction. Energy meeting. Energy leaving patterns that unwind gently through time. By late December, the discussion has softened into reflection. The instruments remain active, but the expectations have calmed. What once felt like a mystery in motion has become a mystery in rest, shifting from movement to memory. The departure transformed into a presence that continues only through what the cosmos chooses to hold. Some scientists have begun writing about the event in broader terms, not as anomaly, not as threat, but as a rare instance in which observation met humility. The universe did not offer explanation, only an invitation to witness, and maybe that is enough. The story of Three-Eye Atlas no longer depends on confirmation or prediction. It has become a question carried through the quiet of the solar system, a reminder that not all journeys end where we can follow, and not all truths arrive in the form of answers. Tonight the sky remains still, the data rests lightly on its instruments, and the silence around this vanished visitor feels less like absence and more like acceptance. Somewhere beyond the heliosphere, something continues its path unseen yet not forgotten. And here on Earth, under familiar stars, we keep listening not to find, but simply to understand that some mysteries move forever beyond our reach, and it's all right to let them drift. Traveller. We've reached the far edge of this wandering story where light fades, questions soften, and the path ahead dissolves gently into the dark. Tonight we trace the quiet arc of something that passed behind the sun and returned changed, leaving echoes in fields and rhythms we are only beginning to understand. And as we drifted through that mystery together, the cosmos reminded us that some truths unfold, not in answers, but in the space between them. The silence that follows Three-Eye Atlas is not emptiness. It is the universe catching its breath, preparing the next shape it will reveal. The sky is still whispering in its own slow language, still writing patterns we have yet to learn how to read. What we witnessed was only one page of a much older journal. Thank you for sharing this moment of listening. In the vastness of all things, our small attention is a kind of reverence proof that wonder itself is a form of participation in the universe's unfolding story. We do not need certainty to belong here. We only need to remain open. Rest now beneath the quiet stars, stay curious. And if this story found you tonight, you may stay for the next.